Okie dokie dokie. Chapter 4. The fabulous concept of elasticity. Probably there's nothing so important as elasticity that somehow makes students, I don't think bored is the right word. Somehow there's a disconnect between how important this concept is and how much students get excited by it. Like it's a 10 on the important scale and a 1 on the excited scale. We have to work on that. But elasticity is a very important economist concept that professional economists use all the time. And if you want to work out in the real world as a business person, understanding elasticity actually is very helpful. Okay, so what elasticities are measures of responsiveness. They're rubber bands. Some things are very responsive. For example, how much gasoline you buy is not very responsive to the price, right? You pull into the gas station, you fill up your tank. You might grumble about the price, you might not grumble about the price, but you're filling up your tank. Okay? If you, on the other hand, are thinking about buying a new computer or a new laptop or some new furniture, you're going to take your time. You're going to look around. You're going to look for a deal. Hopefully you're going to find a sale or a student program to buy your computer or something. You don't want to pay full price. Okay? We treat the prices of things very differently. There are some prices that we care a lot about, and there are some prices that we just pay. Okay, so the first thing we want to look at is this thing called price elasticity of demand, which sounds long and complicated, but it's simple. It's the price elasticity of demand. It's the responsiveness of the quantity demanded to changes in price. So again, the quantity demanded of gasoline is not very sensitive to the price. The quantity demanded of new Macs is pretty much dependent on the price. And if we're talking about refrigerators or washing machines, it's even more dependent on the price. So again, I put these two things up here because they're great examples. Furniture. Anybody who's shopping for furniture cares about the price. We look at the price of that furniture. And whatever that price is has a huge impact. If you go to a store to buy some furniture, go to a furniture store. Every single piece of furniture in the furniture store is on sale. And I don't care what day it is, right? So the new year comes, we get the New Year's sale. As soon as the New Year's sale is over, we get the Martin Luther King sale. As soon as that's over, we get the President's Day sale. As soon as that's over, we get the Easter sale. As soon as that's over, we get, you with me? There's always a new sale. So every piece of furniture is always on sale. On the other hand, when's the last time you went to a gas station and they were having a sale on gas? This week only 10% off gas? No. Okay? So business behavior actually correlates to this thing called elasticity. If businesses understand what their elasticity is, it affects their behavior. Or we can judge from their behavior what the elasticity of the product is. All right, so this is math, and maybe that's why students don't like it, but there's math in this. So the price elasticity of demand is the percentage change in quantity demanded divided by the percentage change in price. Let's say that again. The percentage change in quantity demanded divided by the percentage change in price. So if we look at a product and the price went down by 10% and the quantity demanded went up by 20%, well, that would be 20% over 10%, which is 2. Okay? Now notice that the things we're dividing here are percentages. So elasticity is not in dollars, it's not in percent, it's in nothing. There isn't a unit attached to it. Okay? That's maybe something else that bothers people. They want this to be in dollars, or they want to be, 5%, or it's a number. It sits there by itself. It has no units. There's no dollar sign or cent sign attached to it. There's no percent sign. There's no anything else. There's just a number. The elasticity is 5. Not 5 anythings, just 5. All right? So if the price went down by 10% and the quantity demanded went up by 5%, well, 5 over 10 is a half. Elasticity is a half. The price elasticity of demand is 0.5. Not 0.5 somethings, just 0.5. Okay? That makes it extremely useful because we don't have to compare it to something. If it was in dollars, then it'd be a comparing. But it is no comparing because it just is. It's just this magic number. The percentage change in quantity demanded divided by the percentage change in price. Now notice one other thing. That demand curve slopes down, has a negative slope. So when price goes up, quantity demanded goes down. When price goes down, quantity demanded goes up. That means that technically this thing is always going to have a negative sign, and we're just going to ignore that negative sign. If it always has a negative sign, then who cares? So we're going to ignore the negative sign and just say it as a positive number. Okay? So more concisely, mathematically, we can say the elasticity of demand is percent delta quantity demanded over percent delta price. Delta is a math symbol, and that math symbol means change. It actually means a small change. So it's the percentage change in quantity demanded divided by the percentage change in price. Delta is in there. That little delta is in there to mean the change. Excited? You're excited now, yes? Yeah, I thought so. All right. So let's look at point A on our graph up here. Again, it's regular old supply and demand without the supply. It's just demand because we're talking about quantity demanded. And we're selling whatever it is we're selling at $100 a piece, and we sold 10 of them. Okay? Again, this is all about price and quantity, right? Price on the y-axis, quantity on the x-axis. We have a price and a quantity. Remember that demand is the whole curve, but quantity demanded is the point. So that red line is demand, and at point A, the quantity demanded is 10. So we're really, when we're talking about this quantity demanded thing, we're talking about points on the demand curve. We're not talking about the demand curve. Elasticity isn't the demand curve. Elasticity isn't 5 along that whole demand curve. It's going to change, and it depends on what point we're at. So we're going to look at this point by point. All right? So, because we love to do math, here's our equation, right? The percentage change in quantity, percentage change in price. Now, mathematically, that's delta Q over Q divided by delta P over P. Delta means change, right? So the percentage change is the change in quantity over quantity divided by the percentage change in price. Now you're like, let's suppose that the quantity went from 10 to 15. Delta Q is 5, right? It went from 10 to 15. Delta Q is 5. Then Q, right, is the quantity. The price went from $100 to $90, then delta P would be 10. Okay? It's not complicated. Don't panic. This is one of those things where we get this just by practicing. You practice a few times, it'll make perfect sense. But let's do algebra, and I know that that's scary for you. But you notice we have a delta Q and a delta P and a Q over P, and we invert and multiply fractions. And so we can turn this equation, this delta Q over Q divided by delta P over P. If we do some algebra, that's delta Q over delta P times P over Q. It's delta Q over delta P times P over Q. Now let's go backwards. This is a line. Yes? A line. A line. This line has a slope. And we measure the slope by looking at what we call the rise. And you love my handwriting, I'm sure. The rise over the run. How far up does it go and how far out does it go? Well, strangely enough, the run is delta Q and the rise is delta P. So the slope, and you're saying, why didn't you put this on it? Because there are times when I just want you to see it and write it with me. Go with me. The slope is the rise over the run. The slope of the line is delta P divided by delta Q. Do we see that? Delta P, delta Q. Okie dokie. I can tell you're excited. Why do I care? Well, what's that? That's the slope upside down. Yes? So elasticity is related to the slope of the line. Let me say that again. Elasticity is related to the slope of the line. So again, I'm going to draw you two stupid graphs. Graph number 1 and graph number 2. And I know if one demand curve looks like this, and one demand curve looks like this slope over here, this slope, is very big. So 1 divided by that slope is going to be very small. And this slope is very small. So 1 divided by the slope will be very big. So this tells me this thing right here, this part of this equation, tells me how this line and this line are going to differ in their elasticities. This is going to have a little tiny elasticity, and this is going to have a great big elasticity, and it's because of what their slopes are. Okay? So delta Q over delta P is the reciprocal of the slope. It's 1 divided by the slope. Okay? 1 over the slope. So again, here the slope is huge. 1 over the slope is going to be little tiny. So this line is going to have a really small elasticity. That has a slope which is really small. Well, 1 over really small gives you a number that's really big. And so this line's going to have a bigger elasticity. Oh, it's so exciting.